All right, good afternoon, Geometries period 3 and 4. You can guess who this is, and I'll bet you can guess where I am. But it's Friday. It's the 15th of May. Yay. All right, I'm looking at section 11.3. Okay, we've moved out of circles and sectors and arc lengths, and now we're moving into areas of a regular polygon. Now there's some terminology that you're going to encounter in section 11.3 that deals with something called an apotheme. And I have no idea why it's called an apotheme, but anyway, that's what it's called, but I'll show you what it is. All right, so an apotheme is a distance from the center of a regular polygon to a side. All right, now it's going to be perpendicular to that side. Okay, and that's kind of an important aspect to kind of grab onto. All right, so I want to go through this example right here. Page 612 in your textbook, it shows you the area of a regular polygon. There's an equation, and it says that the area of a regular polygon is equal to 1/2 times the apotheme times the perimeter. Note the capital P. That's the perimeter. Well, how do you find the perimeter of a regular polygon? It's the number of sides times the length of a side. So you can think of that as the area is equal to 1/2 times the apotheme times the number of sides times the length of the side, where A, I'll say it again, is the apotheme, and P, or N times S, is the perimeter, okay? So what I did is I got my best artistic talent out here, and I drew an octagon, okay? Now we're going to find the area of this octagon. Now we're going to start with the length of the side being 4, okay? So I drew some stuff up here, all right? Now notice that from A or C to B, the center of the circle to that dot B, that's the apotheme. The length of the side, A to D, that's 4, okay? Now I'm going to take a triangle. I'm going to take a section out of this octagon, and it's going to look like this, okay? So there it is. Now, I would love to know the measure of angle ACD. Well, you got to remember, this is an octagon. So the measure of angle ACD, to find that measure of that angle, you take 360 and you divide it by the number of sides if you have a regular polygon. In this case, 360 divided by 8 is 45, okay? So now let's take that triangle ACD. Now that I know the measure of angle ACD is 45 degrees, now I'm going to take a portion of that triangle. Ta-da! Now I've got a right triangle. And I should have told you it was a right triangle. I really should have. Anyway, we're missing our little 90-degree symbol on that. Let me get a pen. And let's plop that in there. Otherwise, it makes the rest of our work questionable. Here, we'll even put it over here too. There, okay? So now I know, without question, I'm dealing with a right triangle, because that makes the next thing I'm going to do makes it legal. All right, so I took the section out of my octagon. Then I took that and I cut it in half. So now I have a trig ratio set up. I have a 22.5 degree angle. I have the opposite side of that 22.5 degree angle at 2, and I would like to know the length of A. I would like to know the length of the apotheme. All right, so how you do that? Well, tangent comes to mind. Tangent is that ratio of the opposite side over the adjacent side. So tangent 22.5 is equal to 2 over A. If you do a little algebra, A will equal 2 divided by tan 22.5, and you put that in your whiz-bang, and you get A is equal to 4.8284. So the length of the apotheme, the length of that apotheme right there, that distance from C to B is 4.8284. So how do you find the area of this regular polygon that happens to be an octagon? Well, you go back up here to your whiz-bang formulas, okay? Plug the data in. Area is equal to 1/2 times the apotheme. I even put the A up there for you. Times the number of sides times 4. If you crank all that out, you get 77.2548 square units, all right? Now that was a nice one, okay? Everything come out beautiful and pretty, but what would happen if, now you're gonna love this, I attempted to draw an 11-sided regular polygon, okay? I didn't do such a great job, but anyway, there it is. That is an 11-sided regular polygon, okay? Now, I'm going to do the same thing. I'm going to pull out a section of my 11-sided regular polygon. Oh, and this time I told you that the radius was 5. The radius of this is 5, okay? And I don't know the length of the side. I don't know how long the sides are, so I'm going to find that. Now, I've already got them wrote up here, but let me show you how I did it. All right, so what's the measure of the angle? Well, it's 360 divided by 11. Well, again, I want half of that. Just like I did over there, I'm going to take half of this triangle, move it over here like this, okay? Half of 360 divided by 11, and then you take half of that, and you get 16.36 degrees. And now, I would like to find the length of the apothem and the length of the side, all right? Well, I can use my cosine for this because I know that cosine is equal to the adjacent over the hypotenuse. This will give me the length of the apothem, okay? And if you do that, you crank this in your calculator, you will find that the length of the apothem is 4.7976. Now, these are approximates. They're approximates. I rounded. All right, and then I can use sine to find the length of that opposite side. And if you do that, you find that x is equal to 1.4084, all right? Now, I can find the length of the side of my 11-sided regular polygon. If I double that, like that, okay, I have the length of my side at 2.8167, all right? Now I can find the area of my 11-sided regular polygon by taking 1/2 times the apothem, which happens to be 4.798, times 11, times the length of the side, 2.8167. You do all the arithmetic, and you get 74.33 square units, all right? Now, that's how to find the area of a regular polygon, okay? Now, if you can find the area of one of the little triangles out of that, now you can start to see how I can play games with that too, okay? How much of the polygon do I want? Okay, that's a brief little overcap on chapter 11, section 11.3. I hope you liked it. So that's what we kind of get to focus on next. I'm going to stick one of these on your semester test. I'm going to generate a regular kind of polygon that's going to have an undetermined number of sides, and we're going to go from there. All right? So, brief little overview on section 11.3. Please get these assignments turned in. Most of you are doing a phenomenal job. I appreciate that. And there's actually some of you that are tuning in and catching up. Wow, is that a surprise? So, I'm happy about that. Anyway, considering the whole circumstance situation, I'm pretty proud of most of you. You're doing a great job. And the good news is I know the rest of you can catch up, all right? But we're running out of time, so get with the program. All right, that's all I got for you today. Have fun with this one and enjoy your geometry. Maze out.